Hello everyone, my name is Miguel Prieto and I'm completing my Master's in Experimental Medicine under the supervision of Dr. Bradley Quon. The name of my presentation is Nontuberculous mycobacteria in people living with cystic fibrosis. Imagine that since you were a child, you have difficulty to breathe and you're coughing all the time. Also, 2 or 3 times per year, you're admitted to the hospital for treatment just in order to continue breathing normally. Imagine also that way before COVID, every time you met someone new and every time you did something outside, you had a risk of catching an infection. This is a reality for cystic fibrosis patients. In my dissertation, I studied a special group of bacteria called Nontuberculous mycobacteria because they belong to the same family as the one that causes tuberculosis. These bacteria live in the soil and the water and we are all exposed to them. However, they're only dangerous for people with problems in their lungs, like those living with cystic fibrosis. In them, it can cause 2 conditions, infection or disease. So what do I mean by infection? Infection means that they have the bacteria inside their lungs, but it's not damaging them. 1 out of 5 people progress to disease, we don't know why, and this means that the bacteria is actively destroying their lungs and compromising their ability to breathe. In my dissertation, I studied this problem from 2 different perspectives. First, I wonder how many people with cystic fibrosis worldwide actually have infection or disease by this bacteria. To do this, I performed something called a systematic review, which means that together with my collaborators, I searched all available research studies in this topic and then reviewed, analyzed, and extracted information from them to estimate how big is this problem for the cystic fibrosis community. My results show that 4% of the cystic fibrosis population are affected by this bacteria. This is in contrast to only 50 out of 100,000 people in the normal population. My results are really important for authorities and researchers. Authorities can use it to properly allocate resources and try to resolve this problem, while researchers can use it as a reference baseline to evaluate new interventions and to propose new projects. In the second part of my thesis, I wonder why only a few people advance to disease, and what's the role of patients' genetics in this progression. My results show that those who advanced to disease had a stronger activation of their immune response genes than those who stayed at infection. But because they progressed, this probably means that their immune response is not protecting them but damaging them. These genes we found are really important because they will help us create a test that predicts the risk of progression to disease by this bacteria in people with cystic fibrosis. This way, clinicians will be able to categorize the risk and provide better care for those who have a higher risk of progression, while reassuring those who have a lower risk. Thank you very much.